All right, this is lesson 2-8. We are on the definition of the derivative. We have now switched standards. We are no longer on F, we are on G. What is standard G, class? Advanced derivatives, yeah. So we had basic derivatives for F, and now we are on to advanced derivatives. All right, so what do I mean by the derivative? I really want to analyze how a secant turns into a tangent line, because that's how we formally define the derivative. So first of all, what is a secant? Do we remember what a secant is? What is the definition of a secant line?
Is it like perpendicular to the line?
Not exactly. So it's not perpendicular. So secant line, it just means it hits the line twice. So I don't know if you remember in geometry. Don't write this down. I'm just going to do this really quick. If you have a circle, you would always do a tangent line, which would hit it once, or you do a secant line, which would go right through it. It's very similar in calculus. So in calculus, oh, come on now. In calculus, what we're going to do is we're going to draw a secant line, and our secant line is going to go through these 2 points. I don't know if I want to do a dashed line. I do want to do a dashed line, but I want to do it in blue. I'm going to move this line to make it have the right slope and the right intersection. Okay, this line that I've drawn is the secant line, so I want to label this. This is the secant line. And I think I've moved ahead a little bit, maybe too quick here. So C is the point that I'm really looking at. I want to find the derivative of C. And another way of saying that is I want to find the what of C. What at x equals C.
F prime.
Yeah, the f prime, the slope. I heard both things. I want to find the slope at this point. What I start by doing is I add some number. And in this case, I'm adding h. So this distance right here between C and C plus h is h. So if I move over h, this now becomes C plus h. So you move over some distance called h, and we're going to eventually talk about the limit of h as it gets smaller and smaller and smaller. So as h gets smaller and smaller, this distance here gets smaller and smaller. Can you guys visualize that happening? As h gets smaller and smaller, this point moves on this line closer and closer to the point that I'm talking about. It moves left on this line. And also think about what the secant line is doing. What is the slope of the secant line doing as I'm moving this point, but I'm not moving this point? Eventually, it gets closer and closer and closer until I'm infinitely close to the point C. When I'm infinitely close to this C, I suddenly have what's called the tangent. And I'll do this in red. Red is going to represent the derivative here. And I'm going to try to draw a line correctly here. No, I don't want to do a dashed line. I want to do a solid line. Okay, the slope of that line is going to be about like that, and I'll move it to the right spot.
So that's the tangent?
Yeah, so this red line, this is the tangent.
Wait, so should we draw the tangent but not the secant?
You should draw both.
Wait, how do we know it's a tangent?
So the tangent is the derivative. It is the slope at that point. It is the instantaneous velocity, or technically instantaneous speed, I guess, because it doesn't have direction. At that instant, how fast were you going? I mean, it would be nice to say that it only intersects that function once, but it might intersect it more than once if I have a really large function that does a lot of ups and downs, lots of peaks and valleys.
Wait, so what was the part that we weren't supposed to draw then?
I had a circle up here that had a secant line and a tangent line. I didn't want to draw that, so I erased it. So everything that's up here, I want you to draw. All right, so I really want to spend the time to make sure everyone tries to visualize this as best as they can. Visualize h getting smaller and smaller. Pull this point along the curve of the function, and I call this the curve. I should do this in red. I use this word a lot, but I really just mean the line of the function. So this is the curve that I'm talking about. This function. This is the curve. This is the f of x of the function. So pull this point along the curve, along the function, and that means h is getting smaller and smaller. If I drag this x coordinate over, this point moves along the curve until it gets closer and closer to this point. And eventually, the slope of the secant line will get closer and closer to the tangent line. Another way of saying that is, as h gets closer and closer to 0, the slope of the secant line gets closer and closer to the tangent, or f prime.
Oh.
This is the definition of f prime. This is the definition
So can
of
we
the
write that
derivative.
below?
I'm going to write that in formal notation below.
Wait, so tangent is like the derivative and then secant is the slope?
Yeah, secant is slope. So think about secant as like the average rate of change.
Okay.
But we do think the tangent has a derivative.
Yes, tangent is the derivative. So in formal notation, what I've just said, and informally I'll say it one more time, h is getting closer and closer to 0, and the secant's slope is getting closer and closer to the slope of the tangent. So how do I write that in formal notation? And here we go. And I'm going to use red because everything here that we're going to be writing is the derivative. So what I did is I took the limit as h approached 0. H got smaller and smaller and smaller. This distance here got smaller and smaller and smaller.
Wait, so I know you want to keep it in like notation, but can like we write that underneath, like, because I'm gonna forget that. I feel like as h gets smaller and smaller.
Okay, yeah, I'll move this down and write.
Ew.
What's the U from?
That was gross.
Are you okay so far?
Yeah.
You were like shaking, and like I looked over and you were like looking down.
All right. H gets smaller. Oh my gosh, my pen doesn't like to work when I'm recording. H gets smaller.
I forgot I was recording.
H gets smaller.
It gets smaller.
And the slope, and it's really key here. I'm not talking about just the secant, but the slope of the secant.
Some days I have these.
The slope of the secant gets closer to what?
To the initial point.
What kind
Yeah,
of-
you're saying it kind of right. It's getting closer to this thing. What is this thing that it gets closer to?
Tangent.
You guys you're really close, but it's something of the tangent.
Derivative.
No, the tangent is the derivative. Closer to the slope.
Slope.
Wait, I thought secant was slope.
Secant has a slope, but tangent is the slope, the instantaneous
To
slope.
that point.
Oh.
So it gets closer and closer to the slope of the tangent.
Wait, can I? Oh, just kidding.
Look at this, my writing. My writing is usually pretty good, but my
Not today.
computer. Wow, I'm just trying to say that my computer doesn't have the graphics card to handle it.
I'm just kidding.
It's way better than Mr. Goodway's though. You should see.
Oh my god, the other day.
Pretend that says like something.
He always says pretend.
Wait,
it says-
pretend that's
All right. So now in formal notation, I'm going to write it out. So the limit as h goes to 0, that translates as h gets smaller, infinitely smaller until it basically is 0. Not exactly 0, because then we'd have a 0 in the denominator, and we're not going to have that. Okay, so do you guys remember how we define slope? What is average rate of change again? F of b, all of that stuff, you remember?
Yeah.
Can someone repeat it out loud for us?
average
F
rate
of
of
B minus F of A over B minus A.
You might say.
F of b minus f of a all over b minus a. I'm doing that exact thing. This represents.
Wait, what is that?
Yeah, what is that? That's a good
It's
question.
The formula for average.
Oh.
Yeah.
Average rate. Average rate is this guy. I want to find the average rate of the secant as h gets closer and closer to 0. I want to find that slope of the secant. This represents the slope or the average rate. So I'm basically going to write that. But instead of using b and a, I now have very specific points, c and c plus h. So let's assume that I'm talking about b. My b is usually my second point. So I'm going to say c plus h is my b. So let's sub that in. So I say f of, can you guys write the rest for me?
C C plus H.
F of C plus H, yeah. C plus H. You got it, Carly?
Minus f of c.
Minus F of C. You got it, Kaylin?
Over C plus H minus C.
Oh my god. You did that so perfect. C plus H minus C. It gives me goosebumps, really, because this definition of the derivative is hard. It's really hard. Most people just see this equation, they just like, I'm going to commit this to memory. But you guys see the connection between average rate, and we're able to plug in my description of the secant line getting closer and closer to the tangent. All I'm saying in this formula, and this is the formula for the definition of the derivative, you've got it.
So like basically we're finding
Thank you.
like so we're trying to find the slope as it gets closer. Like is that what the formula is?
Exactly, yeah. I want to find that slope of the secant as h gets closer and closer to c,
Which is
Or-
the derivative.
which is the derivative. Yeah, this is
So
the,
average rate equals derivative.
well, as I get, only when h gets closer and closer to 0. Yes, but you have the
Okay,
basic
so
idea.
Then I could say equals ddx.
Yeah. So,
What's DDS?
wait, what happened here? H minus C. I hit the backspace. Okay.
Wait, who?
Can we
DDS.
can we simplify this a little bit, because there's a C minus a C. So can we simplify this a little bit?
Yeah.
Okay. Can you go ahead and do it in your notes? I'll let you guys go ahead of me. Once you have it in your notes, check on the board to see if you got it correct.
God dang it, I wrote down notes and then now I'm out of room. Oh, I forgot we were recording.
It's okay.
Wait, I don't know what I'm gonna. I guess I'll just like write it.
Alright. Kill.
Wait,
It's
so
your
we're,
staple.
All we did was we simplified the denominator.
okay, because I was like, well, wait a minute.
And what you really found here, this is the definition of, and I'll write it over here in red still. This is f prime of c. F prime of c equals this, and like box this, star this. This is the definition of the derivative. And I hate to be the bringer of bad news, but this is one of the three that we need to know.
3?
Mm-hmm.
Damn it.
Well, I hate to tell you, but you were the bearer of bad news.
All we're doing today, though, is this one.
But this one I feel like isn't gonna be that hard because you kind of already do it.
Yeah, like average rate.
Yeah, so make sure that you have this part 2 over here, f prime of c. F prime of c is equal
How
to
much
this
longer are
thing.
these notes?
I need to do about one more slide.
Oh, cool. Because I want to make sure it fits on one page.
Yeah, I like just doubled up so that I can have it be like a one side and then worksheet here. So if we have 2 pages, I'm gonna be mad.
I'll try to not make you mad, Kaylin.
Like, it's hard.
And
You win.
another thing that's kind of critical to know about what we just drew down here is that f prime of c, this is technically the tangent. But this thing, it's not quite the tangent because it's not at 0. You can see why plugging in 0 into this formula would be bad. Do you see the problem with plugging in 0?
Yeah.
What is it?
You would have
You
0
would
on the
have 0
bottom.
on the bottom.
Yeah, you'd have 0 on the denominator. So this thing only represents secant.
Oh.
It's never a tangent because you can never actually plug in 0. All it is a secant. So by taking
so
the...
it is a tangent, but it's not a tangent.
Yeah, exactly. Because when you take the limit,
That's 2.
when you take the limit, it becomes a tangent, but this main thing right here, this equation is secant. Because it's just average rate.
I don't know about this.
All right. I'm about to teach you our new trick, and it's how to solve AP problems with definition of the derivative. And I call it the hot box.
Whoa! Yummy.
All right. Don't know what Kaylin's doing over there, but here we go, the hot box.
It's just because that's what Nico said.
That's what Nico said what?
I get it.
Get it?
What's like
Take this.
The hot box.
All right, so I'm going to do the procedure on the left, and I'm going to do the example on the right. If you don't like that style, you can just do the procedure and then do the example underneath. So,
I'm really mad at that it's recorded on video.
It's okay, we have of recordings of Mr. Sindel saying everyone's not beautiful.
Nico comes back and Mr. Sindel's like, look at these cool videos.
All right. So here's our procedure.
Nico's like, I knew it.
He's like, you weren't supposed to tell anybody that.
I got like killing.
So we know the definition of the derivative, and I'm going to rewrite that here in red because red represents our derivative. It's our bloody slope. Here we go. F prime of c is equal to, and hopefully you remember this. See if you remember it without looking up above. F prime of c is equal to what? I'm not going to say it out loud. I'm going to write it down. You can check your work with your own notes.
I don't remember Mr. Sindel.
Wait, we did this today?
Yeah.
Oh, you just wrote Lynn. Okay.
Yeah, I'm trying to squeeze all this in here. I should have said limit as h approaches 0.
I thought it was H approaches C. But it approaches C as it approaches 0.
No, so h, remember, is just the distance between c and c plus h. So this distance here is shrinking. It's getting closer and closer to 0.
Oh, yeah.
Oh, yeah.
Have a check.
Nope.
So we're finding the slope as H gets closer to 0, not as H gets closer to C.
Exactly. And that's why we have a problem with the denominator. We can't just plug it in.
Silly goose.
You know what? I'm sick of it.
All right.
What the hell, Jerome?
There are 5 steps for the hot box. First step is to find it. So find the hot box. Find hot box.
I know.
Okay.
All right. I'm going to do all the steps and then we're going to apply it. Step 2.
Hotbox is one word.
What's the hot box?
Yeah, because now you're freaking me out. Because one word and
Is
there's
that the
two words.
secant?
It should be 2 words. I'll go back and fix it.
I apologize.
Wait,
Hot
is
box.
this like a word that you made up or is
It's
it
a word I made up again because it's kind of cool.
on the AP test? We're like, well, here's the hot box.
You have to, like,
Yeah,
write 'em
don't-
down
don't do
saying,
that.
like, when the houses in the hot box go together.
Step 2 is to
This is weird.
get your C. And by that I mean let's put some notes here. Adding to H. This will make sense in a bit. Just trust me for now.
Sometimes you say that, Mr. Sindel, and then it doesn't make sense in a bit. But now because you said that, I can't say anything.
We have trust issues now.
Yeah.
Okay. Because we have the procedure and then we're going to apply the procedure, and hopefully when applying it we'll see scribble. Yep, scribble out the C plus H. That will go away. Step 4.
Scribble out.
Put X
I'm gonna be a rapper.
on scribble.
In Hamilton.
And our final step of 5,
I don't like these steps. I don't get them.
Yeah.
just hold on.
For words I don't know.
In Spanish, the last one.
He does it in Latin.
Look, or I guess you should really just write what's left.
Kel, my F's and T's look the same. So I feel
We'll get
like-
F prime first.
Yeah.
Get
6 is in B.
Except you know
F
there's one,
prime
so it doesn't
first.
matter.
Yeah, you're not gonna have a
Yours get
problem.
mixed up. Because mine just looks like what? And I'm like, what is that? And then,
But you would know.
All right,
I feel like I'm just gonna make my 6.
here we go. Example on the right. Let's see if I can actually fit this in here. So, let's find this one.
I just always think about when you all.
So this is something that you might see on the AP test. Some example. So they want you to find the limit as h approaches 0 of this thing. And it's going to be the natural log. So maybe I should do my cursive L so we don't confuse this for 1.
Not a natural log. What the heck?
Natural log
That was a rough move. Then Carly swallows it.
Of
Spitball.
2 plus h minus natural log of 2. All divided by h.
Oh, okay.
So what they will ask, and I don't know if I should put this, yeah, I guess I should put this right here. They will ask the question. Here's your question.
Okay.
I guess we don't even have to write that. We just have to, the question is, like, what does that equal to? So this equals what? Equals what?
So you simplify or?
Yeah, so we have to use these steps to figure out what it's asking for. This is
I
really
don't even know what this is.
saying something like, find f prime of 5 in this function. We don't know what number we're supposed to put in. We don't know what the suspect point is. We don't know what the point we're trying to plug in. And we don't know the function. But it's somehow embedded in here. And these are the instructions on how to find that.
So I'm
Bless you.
guessing that. Oh.
We take step by step.
Step by
Find
step.
the hot box.
Okay, so here's the hotbox. Are you guys ready to follow along? Hotbox, step 1. Hotbox is where I have extra stuff. So the C plus H, everything in there is the hotbox.
I knew it. That's what I was gonna say.
This guy is the hotbox. I accidentally crossed out
Kill.
my minus, but my minus is still there. I found the hotbox. Step 1 complete. I would check it off, but it'll look bad for the notes.
I heard you say that.
So step 2, get C. What is C equal to? And look at our equation up here. What is C equal to?
Wait, how do we know that that's a hot box?
So hotbox is the thing that has plus H in it. So it says adding to H. Is the thing adding with H. Or sorry, the hotbox. I'm so sorry. Hotbox is the thing that has H in it. It's two terms, something plus something. It'll have plus H in it.
See, adding to H.
Wait, no, it's something plus something. That's it?
We'll say plus H. It'll have something plus H.
Are you okay with this?
I'm so sorry. What is C though?
C is 2.
C is 2. How'd you get that?
It's adding to H.
Yes, you can see that if I plug in 2 for C, this becomes 2 plus H. 2 plus H. If I plug in 2 for C, this is f of 2, or 2 goes inside the parentheses. Yes, 2 is the interior function. So C is equal to 2. We got C.
So we just tell that based on what numbers are in the given problem.
Exactly, yeah.
Okay.
So what numbers are in there? What numbers are inside the parentheses? That's what I'm looking
It's
at.
always gonna be the same number.
This number and this number will be the same. If they're not, then something has gone totally wrong and they're talking gibberish. Because this is the formal function. All right, so let's scribble out the C plus H. Do you see a C plus H in there?
Yeah.
Where is it?
2 plus 8.
Scribble it out. I'm going to do it in highlighter so we can still see it in the notes.
Scribble it.
Scribble it out.
We don't have that
Why, though?
ability.
You guys should scribble it out. I don't want to do it for my notes because otherwise you won't be able to see what was originally in there.
Scribble.
Put X on scribble.
Okay. And then, yeah, so that needs to be turned into an X. So we're going to put an X right here. That is now natural log of X.
Can we rewrite it?
You can put it up above it, or you can, I guess you can rewrite it.
So
But
you just have ln minus ln.
so ln of X, it's not just cross out, it's actually an X.
Oh, I thought it was like a cross. Okay.
Yeah, otherwise I would have said cross out scribble, which wouldn't make sense because scribble is crossing out, I guess. I don't know. But yeah, this is now natural log of X. We did step 4, check. All right, now we're just writing what's left. So what do we have left? We have,
LN.
yeah, we have natural log.
Of X.
Minus.
Natural log.
Oh,
2.
good God. Natural
Divided
log.
by.
Divided by H, yeah. So, I mean, just to stay consistent, yeah, that is rewriting what's left. And what's really what I'm really looking for is finding this first part. This first part in the hot box is the function. We have found the function by doing these rules. What is in the hot box? It's the function.
The
So,
function is ln of x
So-
minus ln of 2.
yes, exactly. Well, it's not minus ln of 2. It's just inside the hot box.
So just x.
No, it's inside the entire hot box.
Oh, yeah.
Okay.
So our function, our f of x is equal to natural log of x.
Wouldn't it be like that for all of them?
Yeah,
Since-
most of
why
them.
do you need to find C then?
We need to find c because we need to find what it's, remember, this is taking the derivative at a point. What is that point? That point is 2.
But isn't the function always going to be ln of x because you always put an x over the numbers?
Yeah.
Yeah.
Oh.
So then, do we ever have to do work?
Well, now we have to do work, so are you ready?
Oh wait, so that was just notes.
So we have to find the derivative.
Yeah, now we have to find the derivative. So what we're really trying to find, and this is like the key part,
Oh, so now we do.
is f prime of, what are we trying to find? Well, f prime of x is, let's find the derivative. F prime of x is,
1.
no, what's the derivative of
1 over x.
1 over x? Perfect. And what it's looking for is f prime of c. So the final thing that I'm looking for is f prime of c, which is f prime of 2. F prime of 2 is
2.
1/2.
1/2.
1/2? Wait, how did we get 1/2?
Because I plugged in 2 for x.
Oh. Okay.
So over here, we got f prime set up.
Because ln x equals 1, so it's 1 over 2.
Yes, and then all we do here is we plug in.
So then our final answer is 1/2.
Our final answer is 1/2. This thing equals 1/2. From all of that gibberish, we are somehow able to extract the fact that this was taking the derivative of natural log at the point 2, and that is equal to 1/2.
So
And 1/2's our final answer.
1/2 is the final answer. Let's go ahead and box it.
I feel like they're going to get harder than that.
Mm-hmm.
They don't get much harder than that.
Really?
Yeah.
Do you?
As like we get like to the paper, it's
Like super hard.
Remember that cool thing Charles used to do?
So, can we also, I don't think this part is really necessary.
and it looks like it's bending.
Because what I really need to write is what's left in the hot box. So this part right here, I'm going to erase it in my notes. You can cross it out. But I want to add to this to make it a little bit more clear. Come on, eraser. You guys see how that's lagging, right?
Yeah.
You believe me now? Can we add in here that this is
It's bending?
in hotbox?
No.
Because we wrote right here that this is natural log of x in the hotbox.
Okay.
I'm just going.
And then adding on a step, just to make sure we have perfect notes, we got f prime and then we plugged in.
Okay.
How about this?
Come on, computer. Plug in
Yeah.
our C.
Did you see it? Ready?
Did your thing
Oh,
just
wait,
pink?
no. I feel like I saw it for a second.
All right, so whenever you see this, whenever you see limit of h goes to 0, you should be suspicious. You should be thinking hotbox. So I'm gonna even write that on the side because that's kind of one of the things I want in our summary.
Hot box.
When you see limit as h goes to 0, you should think hotbox.
We should get hot ones.
And then I'll call them hot boxes. Yeah, because we scribble out the hot box, we eat the hot box.
So just to review, because we're done with the notes. You're gonna write your summaries after I do this little bit of review. So we found our hotbox. That's the thing. That's the biggest part. The biggest thing on the numerator is the hotbox. We drew our box. Then we found C. The C is the thing being added to H. What was being added to H? The 2 is being added to H. Therefore, C equals 2. We don't even care about the rest of the function. We only care about our hotbox. Don't worry about this minus natural log of 2. Don't worry about divided by h. Don't worry about the limit. We're all restricted in the hot box. We knew what c was because it's something plus h, and we found that that was 2 plus h. We scribbled out the c plus h, and in its place we wrote an x, the variable x. We didn't cross it out. So now we have just what's left was natural log of x in the hot box. So that is our function. We took the prime, we took the derivative, and then, oops, I wrote there. We took the derivative, and then we plugged in our c that we found from step 2, and we found our answer. Do we have questions now before we go to our summaries?
No.
All right. That concludes the lesson. Say goodbye, girls.
Bye.
Stay young forever. Never give up. We love you.